Dan. Thank you very much for being here. I saw some projections that say that the market value of the additive manufacturing industry, which you're in, is projected to be somewhere between $35 and $45 billion by 2026. So that is a lot of growth happening very quickly. So could you tell me what you guys are seeing in the industry over there at JuggerBot 3D?
Certainly. You look at the global manufacturing market, it's something like $1 trillion. So relative to the entire manufacturing space, 3D printing is still a small sector, but it is growing quite aggressively. Our focus at JuggerBot 3D is more on industrial applications. So we're more focused on not just even business to business, but applications on the production floor, tooling and end-use parts in particular, which I think is where it's the least tapped into portion of the total 3D printing space. And there's a lot of excitement around it because it doesn't just change how products are designed or how they're made, but also can change how we as consumers are buying. So it's really, from a holistic perspective, has a lot of potential to disrupt, even though I hate to use that word sometimes, to really change the way businesses are functioning.
Talk a little bit, you make some pretty big machines.
Right.
They're big. They're like, I don't even know what to really
like
compare
Humvees,
them to.
basically.
They're like a small car.
Yeah.
You know what I mean? Or even
a big car.
Or a big car, yeah.
Sure.
So I guess, could you talk a little bit about what your machines are capable of making and how some of your clients are using that on the production floor?
So our flagship line right now is called the Tradesman series. And actually a lot of the motivation for them came from more traditional CNC equipments like mills and lathes, both for how they would be utilized, especially compared to how most 3D printers traditionally have been utilized, not just for prototyping or Yoda trinkets. Even though those are cool, there's a lot of opportunity on, again, production floors. So our Tradesman series P344, which is our standard pellet-fed system, prints very fast. It can print with a lot of different functional materials, and we're seeing a lot of success in production tooling applications. So, specifically, you're looking at molds for composite fabrication, so parts that would be made from like laminate fiberglass or carbon fiber, parts that are being molded from thermoplastic sheets, parts that are being cast out of metal, the pattern specifically
so
for
we're talking
that.
about parts that can actually be used as opposed to just a prototype that then I'm going to go make the actual part.
Right. Big functional parts.
And are these parts that perhaps the company is only going to need a few of them, so it may be cheaper to make it this way as opposed to I'm going to need 10,000 of them?
Yeah, well, yes, the answer is relative to whatever a normal production volume would be, it's low volume, high mix is really where we still play a lot of the time. We're just seeing, I think that definition kind of transform a little bit. It's kind of changing the shape of what is low volume and what is a relatively diversified portfolio of product from a design standpoint, right? And so that's why I think tooling makes a lot of sense for us, but we are seeing a lot of opportunities and more traction on production parts because businesses are starting to understand and be a little bit more, I think, comfortable and confident in being able to deploy a production strategy or a commercial strategy that's tied to a more segmented approach for addressing customer needs, right? Okay. By being more specific with the kinds of products that they're putting out into the field and saying, well, I can start making things in the thousands or tens of thousands profitably because of 3D printing in addition to other manufacturing technologies, as I could be with doing a million of something and hoping that this one-size-fits-all approach suits, this big demographic of people.
Right.
Yeah. The other thing with tooling that thinks is a lot of sense is, especially right now, that's where we see so much delay in start of production timing. So there's so much complexity and there's so many challenges that manufacturers are facing right now to just get products out the door that the long lead time piece of it, being able to be a little bit more agile with how you are ramping up production or going through design iteration is a huge value add.
Well, I wanted to talk about the supply chain. We can't not talk about the supply chain.
Sure.
I'm getting sick of talking about the supply chain.
Yeah.
But 3D printing, as you kind of talked about, could be a solution to help localize a supply chain. You could perhaps have a whole bunch of 3D printers set up at a local place, and whatever part is needed, you can literally just kind of like create it right then. It doesn't have to come from overseas. So
Right.
could you talk a little bit about how that perhaps could help with some of the issues we're having right now?
Yeah, so I think it all kind of falls back on the fundamental benefits of 3D printing, and that kind of sum up in the three is design freedom, first and foremost. You're not subject to the same type of limitations you are with traditional manufacturing, so that does help. But also the fact that it's a toolless manufacturing process. You don't have to worry about having a mold or a die or whatever it may be and a press set up to do so. You just have a 3D printer, materials, and as long as you have somebody who's a competent operator and designer, you're good to go. And then the agility that surrounds both of those things is really valuable, especially in times like we have today. So, I think one of the companies that we work with, one of our customers, they're more like partners, is a company called BDI Additive. Mm-hmm. And their whole 3D printing business is really based off of being able to address these long lead time items that are keeping multi-million-dollar production facilities from being able to make product. So they're addressing not just obsolete parts, but parts that are now coming, they're going to be shipped overseas and it's going to be 30 days or even 7 days that's coming on plane and subject to potential issues along the route to the production facility. Hey, we have JuggerBot's 3D printers. We have a competent team. We can take the part that you need, reverse engineer it, or sometimes be able to create from scratch a design that's going to be worthwhile, print it on site, and have it to you guys in a couple hours or a couple days,
right,
so that you guys are up and running and doing what you do best.
It's almost, to me, it almost sounds like the shift from physical media to digital media. So like if I want to buy an album, they're literally just sending me the file now.
Yeah.
Do you know what I mean? I don't actually get to hold it.
Digital distribution, right?
So so basically it's like I need this part for my for my operations. This guy over here has it. All we need is an internet connection. I need this printer.
Absolutely.
And he or she's going to send me that file. And so I guess, is that something that's going to start happening where almost the intellectual property is going to be kind of the thing people are selling as opposed to the actual hardware?
We are seeing some people that are starting to get in that space. I think there's certain companies that are set up to be platforms that leverage digital distribution.
Yeah.
So kind of like there's a bunch of people, there's a bunch of companies now that are starting to grow as the Spotifys of 3D printing, if you will.
Sure.
But they're setting up the supply lines, they have the customers, they have the vendors, if you will. And I know that there's some OEMs and people that are, that own the design that are starting to realize that this is something that they can utilize and leverage as another go-to-market strategy. Mm-hmm. And I think that we'll just keep seeing more and more people take advantage of that route.
I want to talk a little bit about what you guys, some more about what you're doing, but I also wanted to take the chance to ask you, for some people who are out there who are thinking that perhaps 3D printing could benefit their business, could you talk a little bit about some of the benefits and then maybe some of the misperceptions that or some of the pitfalls businesses who are trying to adopt this technology could encounter when they're doing it?
3D printing is an umbrella term that captures a number of different techniques, right? There's a lot involved there. So my perspective is, being that I've spent 8 years now really focused on 3D printing, is every business that makes something or designs something can benefit from 3D printing in one way, shape, or form. Where people normally fall off, where people are not able to make good use of the tool, is when they are looking at the wrong type of tool. Mm-hmm. So I think it's really critical that first and foremost, anybody who's looking to get into 3D printing, leverage any local resource or any resource you can find, because even you can find experts that are just writing blogs and providing good content that you can learn from online from all over the world. But look to those people who can better help you, better guide you along the early stages of the journey. So we as an OEM, that's something we really strive to achieve. And we always tell people, if you have a need or if you're interested in learning about 3D printing, get a hold of us, because even if it's something that JuggerBot can't help you with, we can at least point you in a direction. Companies like America Makes, they're really big helps and a great resource for companies that are looking to, again, navigate the 3D printing waters. And so there's definitely resources out there that will help you in some way, shape, or form make good use of the technology, whether that be as a more traditionally a prototyping tool, something that can just help you print your designs out fast, get them in hand, and say, yes, I like this, or no, I don't like this, make changes without having to go through the time and expense associated with more, I should say, more conventional ways of prototyping,
Right.
or if it's something you're actually going to use for, like our customers are, for production tooling, for production aids, for production parts.
Is there any, and this is just off the top of my head, is there any concern when people are making parts for their production floor? This thing's got to stand up. Are there differences, I guess, or are there are people maybe a little standoffish or reticent about adopting it because they're going, look, I can buy this part from my supplier, and if it breaks, I can sue him or something.
Yes,
Do you know what I mean?
absolutely, absolutely.
Like there's a little bit of a guarantee, I guess. You know what I mean?
Right.
As opposed to this thing that I printed over here, and now when it breaks, like, who do I blame?
Right.
So
there's a certain level of diligence that has to go into
Right.
making parts for functional purposes, and that's, I'd say, like 70% of our time with prospective users is going through the validation steps.
Okay.
And one of the biggest things for that is the material you're using, as well as understanding, obviously, how the process is going to work, which we can touch on, or we can refer to guides that'll kind of show that. But the material is a huge element of it. In our space, the application is going to drive material 100% of the time, and then the material is going to drive what 3D printing technology you can use. So that's one of the things that's also exciting for the pellet-fed systems that we've developed downtown here, is that there's only, say, hundreds, maybe thousands of filaments that are available, or or powders that are available, or resins that are available for the other 3D printing techniques. But there's tens of thousands, if not more, of pellets that are available, because pellets in thermoplastics, at least, that's what's used and has been used for traditional means of producing plastic parts for decades. So since you kind of unlock, you open Pandora's box in a lot of ways, and that's also something that helps you, again, go back and say, is this a critical part for this application? What happens if this fails? And having an analysis there, and then saying, well, this is the best material for that, and this is the best way to build that, and then actually being able to lay out a development plan that includes testing to make sure before you put that part on that, is this going to live up to our expectation, or are we going to be in,
Right.
a bad way?
Yeah. Okay. But it should be noted also that people are using this stuff on planes.
Oh, yeah, absolutely.
You know what I mean? Like this stuff will hold up if done correctly.
100%.
You know what I mean?
There's I'm not going to mention who the name is, but there's a defense contractor. I guess defense and aerospace is the entire business, huge business.
Yeah.
They gave one of their lead additive manufacturing engineers gave a really good presentation at a trade show we were at, that we exhibited at in May, that just outlined and detailed all the work that this 12-person team has done in the past, since 2012 or 2013 when it was established. So the past 9-10 years here. They went for the first couple years, it was just prototyping and getting the hang of it. And they had 3 people, and then they had 5 people, and then they bought more machines, and then they went through a certificate process, so that, again, 9 years later, there's 12 people. They've got over 300 parts that are being made for production, some of those that are very critical. But they've taken the time to go and they've done the diligence, they've done the work to be able to prove that that's all going to work for them.
Right.
Yeah. So there are, to your point, absolutely, there are critical parts that are being made for in the most pertinent ways out of 3D printing.
Well, let's talk a little bit about some of the work that you've done. You've worked with the Defense Department, the Department of Defense, doing a little bit of experimenting, so to speak. Could you talk a little bit about the project that you were a part of? The
work that we've done for specifically the defense industry is broken down by technology readiness. They have different levels and grades, and we've done some that are more commercial ready, we'll say. It's a lot where our filament or pellet style 3D printing has come. But in 2021 specifically, we had this project that was an earlier technology readiness, so more of a development project with the United States Army and Penn State Barron. And so that was focused on a more unique 3D printing technology that we call direct ink writing, which is essentially a way to print thermally cured composites, specifically thermoset materials that are more similar to what you'd find with traditional thermosets, so like rubbers and silicones and epoxies, than what you find with most of the thermosets in the 3D printing space. A lot of thermosets in 3D printing are photopolymers, so they're cured with light. And while there's advantages to that, there's also there's not a lot of history behind them. It's kind of like the issue with powders and filaments. There's limited supply, there's limited historical data to reflect on. And in some cases, you just have applications that are a ripe fit for traditional thermosets. So that was a project that went on for 6 months, and we are basically establishing a foundation of, technical specs based off of specific materials.
So what were you hoping to find out?
Yeah, well, kind of go back to your point to say, if you're going to put a 3D printed part in a critical application, you have to understand how the part's going to work.
Right.
Right. So that doesn't come without data.
Right.
And this was really the first foray, I should say, for this project. It was, because we've been doing it for a little while now, a continuous effort to establish that data set, that like foundation to say, based off of the process and the materials, if you print, this specific, let's say this specific formula with this printer configuration and these process parameters, we can create test specimens that then can be put through a number of different processes and procedures, and that data will help us better understand how it can be applied to aiding essentially the Department of Defense.
So hopefully at the end of the process, you're able to maybe say, and correct me if I'm wrong, kind of like, oh, we need this part and it needs to be able to perform this way and it needs to stand up to these conditions. And, C chart A,
right.
we did this one. This will have, these properties. It will be this shape, and you know what I mean. And you can almost just like, now that's the part you need. Well, that's the material you need.
Yeah. So this was a 6-month project. There would be there efforts after
down
that.
The
but
road.
Yeah, what we're doing is we're saying these are all the different applications that could be addressed with this specific type of technology. Right. And that's a need right now for the Department of Defense. And they'll lay out, like, say, a dozen different applications. And then you complete this first leg of the work, and all those learnings can be used in 2 ways. You can say, all right, so this data set is now going to tell us that we are on path for, say, 3 of the 12. Mm-hmm. And then in order to be able to address the other ones, we have these concerns, which are more technology development, or we can do more, I should say, process development to be able to address those 3 more readily available applications.
Right.
So you're just continuing to build out the confidence level, both from a technology capability standpoint and from a process capability standpoint.
Okay.
Yeah.
Any of that going down the road any further? Anything else that you guys are going to?
We have. We were just informed that what would be like leg 2 was included on a proposal made to Congress essentially for 2023's fiscal year, which would be a huge benefit to that technology, to JuggerBot, yes, but to also to that technology, because that development time comes with resources. And so this is a project that, the funding essentially would be used to really focus on the development from a material standpoint, from a software standpoint, which is really a big thing for direct ink writing, and then from a process capability standpoint, and be something that we're pretty confident could take us from an early technology readiness to a commercial ready project, a commercial viable technology in just a couple years.
717 Credit Union. Business services designed to meet your daily needs. Commercial loans, business deposits, merchant and payroll services. 717 Credit Union. It's knowing you were treated right every time.